taking a look at the beginning of our coke handling project, which is where the coke is fed from the coke yard onto a grizzly system which covers our reclaim feeder. This grizzly that we're looking at is made out of 1-inch flat bar in a egg crate configuration with 9-inch by 9-inch squares, such that none of the large lumps greater than 9-inch will pass through into the reclaim hopper, so that our feeder located below will not become plugged. The material is being fed from the coke yard grizzly. It drops down from the reclaim feeder into the reclaim feeder, which is what we see the excitation of by all of these springs. The reclaim feeder has an amplitude of about 5/16 to 3/8 of an inch stroke. It continues to vibrate, clearing all of the material then into the feed skirt of the coke to crusher conveyor. Okay, we're panning on the coke to crusher conveyor system as we exit the end of the reclaim tunnel and enter into the first section of the tubular conveyor gallery. We progress up into the magnet tower, where our magnetic separator separates any large magnetic particles from the burden of coke on the belt. This device is an electromagnet which will pick up any tramp metal that happens to be embedded in the load of coal. The electromagnet travels at around 350 feet per minute, so that in any piece that it does pick up will move off of the area very quickly without getting wiped off of the belt by the surcharge of material on our conveyor. The belt continues up into the tubular gallery that runs to the crusher tower. We're actually feeding the mill in spurts at the moment, probably at the rate of around 150 tons per hour, which is a little bit over design, but since we're feeding intermittently, the mill can handle it. Where it is then transported in the coke to boiler conveyor up into the boiler structures, where it is individually fed to one of the 3 boiler silos over boilers 8, 9, and 10. We're panning again on the continuation of the coke to boiler conveyor. We see the tubular gallery extending up to the head house of that conveyor, which consists of the drive. In the foreground, we see the dust collector bag house that picks up all of the dust that's being generated in our coke transfer, cleansing it and discharging it back into our number 1 and number 2 coke conveyors, which are drag chain conveyors. Underneath the structure, we see some shooting arrangements so that we can divert the coke coming up the coke to boiler conveyor either into the number 1 coke conveyor, which feeds boiler 10, or the number 2 coke conveyor, which are feeding boilers 8 and 9.
Coke is stored in the coke bunker above the feeder. The coke falls onto the feeder when the coke valve is open. There is a Level Art 1000 detector which indicates when this pipe is clogged. The coke falls onto the feeder This is a Merrick gravimetric feeder. Once on the belt, it is weighed. The coke drops off the end of the belt where it free falls down into the pulverizer. There is another indicator here which indicates when this pipe is clogged.
Okay, this is the line where the material enters the pulverizer. It comes directly from beneath the weigh belt feeder, drops down through the stainless steel pipe, and goes directly into the bottom of the grinding chamber.
At this time, we'll take a listen at the mill so we can hear it in operation. Sound of the gear reducer. And the sound of the 300 horsepower Siemens Alice motor.
We have an air seal, air supply coming in that supplies air to our rotary air seal. This air seal distributes air through this red flexible hose out to each journal. The purpose of this air seal is to keep an airlock on the journals to keep the dirt out. Also on this seal we have a automatic lubrication system. This lubrication swivel located inside this green hose comes down through this distribution block and comes out the distribution block through the conveyor of the green hose to the suspension shafts and also the main journal shafts. Okay, the air seal, this is where the air seal line comes down into the journal. What it does, it provides air pressure into this area right here, which keeps dirt and material away from the seal. Okay, this is our discharge chute. What this chute is for, it leads into the bottom of the grinding chamber, and any pyrites or any hard to grind obstacles that get inside the pulverizer can fall down through this chute and exit out the bottom of it. So periodically, this chute is open, as I will now do, to discharge these pyrites. Normally, as you can see some of the material coming out, normally they have a this is just a sample of material coming out. Now as the feed is ground up, the feed is lifted up by air into our classifier. The fine material passes on through, and the coarser products are knocked back down for regrinding. Once the material is fine enough, it leaves the classifier through that large 24-inch pipe that we'll call our product line. It comes on around the 90, down as you follow the line, on in to the exhauster. The exhauster conveys the material on up through the pneumatically controlled coke valve and on up into the diverter valves. Bingo.
The coke and air stream is split into two by this splitter. It's split into two streams, one on the right and one on the left. Each of these streams is again split into two, giving a total of 4 separate coke and air streams.
This is the burner elevation. We have two main burner levels. Upper main gun and the lower main gun is located at the bottom. In the center we have our pilot and our natural gas elevation. Natural gas comes in from the side. This is the elevation where the coke is blowing in.
What you are now looking at is a coke flame as depicted by the black sections that is interspersed between the pitch that is being burned on both top and bottom. This coke is being introduced at a rate of 22,000 pounds per hour by means of 4 burners located tangentially around this combustion engineering tangentially fired boiler. The coke has been ground to a fineness of 90% minus 200 mesh. The ash content measured at the baghouse is measured at 99% burnout with only 1% carbon. The handheld terminal, you can use this terminal to adjust the mill parameters, for instance, to adjust the fineness of the grind or the delta pressure that's in the mill. You can also use this device to monitor any of the parameters of the mill, including delta pressure, mill speed, and others. A diagram showing the present status of the mill. It shows the most important of the mill parameters, and it also graphically shows the mill and the various motors. For instance, this is the mill motor. It's running at 74 RPM. Delta pressure here is about 6 inches. This also shows the spinner motor, which is at 55 RPM presently, and the exhaust fan. Outlet temperature here is 200 degrees Fahrenheit. The inlet is 325 degrees. We are feeding coke at a rate of 13,400 pounds per hour. At this time. We're drawing a little over 200 amps on the mill motor. Adjust the mill parameters, for instance, to adjust the fineness of the grind or the delta pressure that's in the mill. You can also use this device to monitor any of the parameters of the mill, including delta pressure, mill speed, and others. Okay, to the right of it, would you explain those bar graphs?
These bar graphs show the most important of the mill parameters, including the airflow in the mill, the mill temperature, mill speed and amps, spinner speed, differential pressure, and the coke air fuel ratio.
A diagram showing the present status of the mill. It shows the most important of the mill parameters, and it also graphically shows the mill and the various motors. For instance, this is the mill motor. It's running at 74 RPM. Delta pressure here is about 6 inches. This also shows the spinner motor, which is at 55 RPM presently, and the exhaust fan. Outlet temperature here is 200 degrees Fahrenheit. The inlet is 325 degrees. We are feeding coke at a rate of 13,400 pounds per hour. At this time.
And how many amps?
We're drawing a little over 200 amps on the mill motor.